Okay, guys, let's get started. I just handed out two reading assignments. One is the behind the growth in materials requirement planning, and the second one is Toyota Motor Manufacturing USA. First one is the very well written paper on MRP, how this material requirement planning is worked, and what's the limitation and what's the assumption and the like. So it includes very simple examples in the paper. So I'd like to ask you to read it and understand it. And if you have any question, ask a question during Monday's class. Okay? In today's class, I briefly introduced how this MRP is working, but I think this paper is more better material to understand this MRP. And second one is about Toyota Motor Manufacturing, and it includes the story about how this Toyota production systems has become the current Toyota production system, and what's the philosophy behind it, and how their production system is working. I'd like to also ask you to fully understand the story about this Toyota production system and these two reading assignments. If you have any questions, raise the question on Monday's class, which means you guys are supposed to read it until Monday. Yep. Okay, for Sang-Hwan Kim. Okay. Question? Is he sleeping over there? Call him up. Okay, let's continue. So far, we talked about some models of inventory control, how this inventory, which is the material, can be optimized in variety of sense. And there are lots of assumptions from EOQ to the QRN model. There are lots of assumptions, and if you relieve some of the assumption, the model has changed from EOQ to news vendor or many other things. The assumptions are introduced in order to make our problem simpler, simple enough to mathematically formulate. Okay? If you don't have much assumption, then the model is very difficult to understand and construct. However, it will simulate the real world more closely. Okay? Rule of thumb of the modeling is it's better to make it simpler, just enough to capture the key characteristic of the real system. Okay? Not more, not less. That's the key of the modeling. However, among all models we've discussed so far, we said there is no interaction between parts. Every part or material are independent, right? But there are dependent demands. And this MRP is the most straightforward and simple planning tool to handle this dependent demand. Okay, MRP is acronym of Material Requirement Planning. And there are many other terminology with the same concept, MRP. And have you ever heard about ERP system? KAIST also has an ERP system. You know, the employer are supposed to log in to KAIST ERP system, and if you apply for some business trip, then you have to do something on the system, and your advisor professor has to confirm it because he has the authority, and all these things are handled through ERP. Many larger company has ERP system. It's conceptually, it's a expansion of material requirement planning. Material requirement planning is a planning tool or methodology to model how this dependent demand can be taken care of. And in this system, what they want to know is what and when and how much about the inventory or part flowing through the manufacturing system. Okay? If you expand this part or inventory into more broader term, in ERP, they were not dealing with material. They were dealing with all kind of information, dependent information. Okay, so many companies, even though they are not manufacturing company, has ERP system. There are some variant of MRP, closed loop MRP or MRP2, and the name is a little bit different. MRP2, it's a manufacturing resources planning. Okay, can you observe the expansion of concept from material requirement handling? What material is required when? And MRP2, manufacturing resource planning. Okay, it also deals with the material, the part, as well as manufacturing resource. Manufacturing resource, in order to manufacture, you need part, as well as some tool and some resource. Okay, this MLP2 is proposed in order to this additional information, and if you go further, it could include all the information which is ERP. Okay, these are the questions this MRP are trying to answer. How much of an item is required, and when is required, and what kind of relationship are there between, among the parts. Okay, there are something called master production schedule. Okay, this is time plan. Time is a very good time in this schedule. Plan, basically plan versus schedule. Can you distinguish plan versus schedule? What's the plan and what's the schedule? Are they different or are they same? In this production engineering field, if you deal with when or time information, then it is schedule. Other than that, it's a plan. But have to be very careful. In EOQ model or any other model, we talked about all information which is related to time. Annual demand, lead time, demand during lead time. So time information is there. So then is that a schedule? Not really. Those time information is about capacity, but this time information is about when. On Monday or Tuesday at noon or 3 p.m. or something like that. When to do. How long to do is different from when to do. Hours are different from, how much time is different from when is the time, right? Can you see the difference? Okay, that's the difference between plan and schedule. Okay. Okay, this MPS is a time-based plan specifying how many and when a firm plan to build each end item or planning unit. Okay. Master production schedule is related to this aggregate production plan, which is called APP, and master production schedule is MPS. Okay, let me explain a little bit further. Aggregate production plan is kind of mid-range production plan. Okay, you know, in shipyard there are many levels of abstraction. Actually, in shipyard, work is done by some work order. It's a sheet of paper, and it has information which are required, or every information you need to do some work. So if you're a worker, you will assign some kind of worksheet. The worksheet has some kind of drawings. This is the part you are supposed to work on today or during one shift, and those drawings has a specific instruction. Welding this line with some other tools, and then weld this line or turn over, and like very detailed information. So if you do step by step, if you do follow step by step the work instruction written on worksheet, you can do the work. This worksheet also contains the information what kind of tool you need to do the work. So if you assign this worksheet, you have to check that if you have all the required tools to the work at the beginning of the work, and it has some time plan. You have to do this much more work in 4 hours or 8 hours or so. Okay, that's very detailed production plan. But we cannot do at the same time. We cannot do those level of production plan when you build a ship. Okay, sometimes people have to do the planning just block by block. Well, this block can be constructed in 2 weeks or so. The rest of the detail don't care because it's too much of information. So they do this kind of, they actually control the level of detail of the production plan, because virtually it's impossible to consider everything at the first place. Okay? Aggregate production plan is in manufacturing system is as the word aggregate means, it's a kind of mid-range planning. In shipbuilding, it could be translated into the block level or sub-assembly level production planning. The more detailed production plan can be ignored. Okay? Master production schedule is the top level production plan. According to this definition, it's a build each end item. In shipyard, what's the end item? What's the final product? Ship, yes. So, in shipbuilding industry, this master production schedule is dry dock schedule. You know, in shipyard, they first determine everything by dry dock schedule. In Korean, we call this is 선표, dry dock schedule, because as you discussed in reading assignment, homework number 2, the goal, in shipyard, what's the slowest? What's the constraint? It's a dry dock, right? Do you remember the name of the boy? Who are the slowest? Harvey, yes. What's the Harvey in shipyard? Dry dock or launching, some kind of launching system. Okay? Because this dry dock is most expensive resource, and it's a dry dock. It's a bottleneck. Every ship should be delivered through that dry dock or launching way, and usually it's a not quite common in Korean shipyard, but most of the worldwide shipyard, they have only one or two dry dock. But in Korean shipyard, there are multiple dry docks or floating docks and the like. Okay? Because they produce too much of ships at the same time. And as far as I know, for example, Hyundai Heavy Industry has 9 dry dock and 2 floating dock or something like that, and which is the world's largest shipyard. And anyway, because this dry dock is the most scarce resource, and it's the Harvey and most slow and bottleneck of the system, and also it's directly related to the final end item. So without knowing the existence of the theory of constraint, shipbuilding industry has planning at the top level based on this dry dock schedule. Okay, based on this book, what would be the strategy then? Building another dry dock is really expensive, and in most of the shipyard you don't have the space to make the dry dock. So what did you write on the discussion about the book review? Well, floating dock is easier solution because it is movable, but you can do the same process which requires the dry dock in floating dock without the use of the dry dock. And the other thing is, Hyundai Heavy Industry has performed several times and what they call land construction system. They build ship on the ground without using dry dock, and they just launch the ship or offshore structure from land to the sea directly. Why? Because is it more easier? No, because they wanted to avoid the usage of the most slow resource. Okay. Master production schedule for shipyard. This is the dry dock schedule or ship schedule or ship table. I don't know direct translation of this, but top level schedule of the manufacturing company is MPS, and the next level is aggregate production planning, and the next level is detailed production planning. They are feeding each other their own information, but okay, the reason I talk about MPS while discussing about MRP is because you can apply the MRP at MPS level or APP level or detailed planning level based on the level of detail you want to see. Okay? Okay, if you choose MRP based on master production scheduling, and this is more easier to explain. Okay, let's take a shipyard for example. You got order to build a ship, some ship like a container ship, okay? And when you get order, you have to first look your dry dock schedule. Is dry dock is available at that period? Well, we know that based on our experiences that in our shipyard, construction of this specific container ship takes about 18 months. And when you sign the contract, you have to specify the delivery date. And before the delivery date is 18 months is available on your dry dock scheduling, you first have to check. Because your shipyard is not brand new, you keep constructing and delivering the ship. There is working process in your dry dock. So based on this working process, you have to squeeze some time, some required time for your ship. Once you sign the contract, now you have to do the next level of scheduling. But so think about this MRP in that way. Okay, so first MRP creates schedules identifying the specific parts and material required to produce end item, and determines exact number of items, and also determines the dates when to order, right? And when to get that thing based on the lead time. You know, for example, you need some engine, and you know that if you order an engine, it takes about 6 months to be delivered. So 6 months is a lead time. Okay? Then you have to put the order 6 months before actually when you need the engine. Okay? Okay. Can you see the lines between here and there? And this one is connected here, this one is connected here, and there is a line here and line here, which means material planning, MRP, is at the center, and it gets the information from bills of material, production breakdown structure, and it gets the information from inventory record file. For example, you know, based on this is the container ship you want to make, and in order to make that container ship, you know how much steel you need based on these bills of material. And you know, in your stockyard, there could be some kind of inventory already. So you have to check the inventory record, and also based on this bill of material, you have to do this planning here. When engineering design changes, you know, you have to build a new, not totally new, but new bill of material. So they have some kind of information flow this way, and based on your inventory transaction record, your inventory database should be updated, and orders from customers and forecasted order from unknown future potential customer. Based on that, you have to set the master production schedule. Okay, that's how this thing is working together. basically. Okay, so let's explain with some example. It's a product structure tree for assembly A. In order to make A, you have to assemble B and C. 4 of B are required and 2 of C are required to make a 1A. Okay? And in order to make B, you need 2 D's and 1 E's. And in order to make C, you need 3 E's and 2 F's. Okay? If this is the product structure time and you have this kind of lead time information, lead time of A is 1 day, F is 1 day, E is 4 day, and the like. And demand, you can calculate this kind of demand. You need at day 10, 50 unit of A and 20 B's and 15 D's. These B and D's are not for A, it's for spare. Okay? If you have this kind of information, you can build this kind of chart backward. At day 10, you need 50 A's. So A required is 50. But when everything is prepared, you need 1 day of lead time. Given here, 1 day of lead time. So order should be placed before day 10 by 1 day. So on day 9, you have to put 50 order. And at this place, you have to have B and C ready. Okay? 50 of A, in order to make a 50 of A, you need 200 unit of B at this day 9, right? Because of this structure information, bills of material. Okay? And, in order to make B, you need 2 days of the lead time. Also, at day 8, they need 20 more B for spare. So at day 8, they need 20 more as spare, but it needs the lead time of 2 days. So 200, 2 days before, at day 7, they have to put the order to make a 200 unit of B on day 7, and at day 6, they have to put 20 orders of B, right? Because of the lead time. And if you do this repeatedly, right? Look at that. You need 50, you need to put the order of 50 A's on day 9. And when you put an order, all the parts should be there. So for the 50 A's, you have to have, because 2 units per A is required, you have to have 100 units of A at day 9, and day 9, for part C, lead time is 1, so you have to put order of 100 C on day 8. Okay? Look at that for D. For 1C, you need 3D, and the lead time is 3 days. Okay, so in order to satisfy this one, this is how the dependency propagates. Okay, you need 300 units to make here, to put order to begin with. and the lead time is 3, so 300 should be go here, and those, according to this bill of materials information, the dependency of part, dependency of demand, all these things can be propagated to like this. Sorry. Okay, if you have this kind of chart completed for your final product, then you know what to do on when, right? For example, on day 1, you don't have to do anything. But on day 2, well, you have to put order of at least 20. Okay? 20 of E. Okay? Something like that. Okay. Closed loop MRP, as I introduced in the first slide, is nothing more than just checking, once again, based on the feedback. Okay, do the MRP and check, is it really realistic or makes sense? Then, based on this MRP, vice versa, from master schedule, the top level schedule and capacity plan and all the information, if this makes sense, you do the MRP and feedback again and again and again. That's the how this closed loop MRP. The key idea is that just do the MRP one time and forget about it is not the good approach. In closed loop MRP, do the MRP and check everything versus with your capacity, resource risk, and all other things. And if there is something mismatching, and you feedback and do the MRP until everybody is satisfied. That's the key idea of this closed loop MRP. And manufacturing resources planning, MRP2, is not only monitor the part or material requirement, it monitors all resources of manufacturing, such as engineering. It's a service required, and finance, marketing, and manufacturing. It's an expansion of the concept. Not only the physical material, but all other things which are required for the manufacturing. Okay? Engineering department does not produce any physical things. They provide some information or knowledge or design decisions. But you cannot put all heavy things. I mean, the basic line is engineering department also requires some lead time. I mean, if there is a ship, okay, do the structural analysis in 1 hour. Not possible. Okay, for a huge ship, structural analysis may take about a week or 2 weeks. So engineering service has the lead time. Also, number of engineers are limited. It has capacity, some kind of. And in engineering department, well, for the ship total analysis, you need to analyze structure, hydrodynamic, engine propulsion, and the like. There are demand dependency. In order to do this kind of analysis, some other analysis should be done first. And in order to do that analysis, some other information should be determined first. So we can apply this MRP to the engineering services. In finance, same story. Marketing, same story. So MRP2 is the expansion of this material requirement planning to all the resources required in manufacturing. So if you have this one, you can actually simulate the manufacturing system. But that's not all. people tend to expand once more, and not only the material and resources, it also includes every possible information. Okay, basically it's a backward scheduling from the due date and backward. And this one is like this. In order to meet the due date, it backward schedules, and at that time, at day 7, you need to put order of something, which means you are giving orders to start the manufacturing, which means schedule pushes production. Work center performance is measured partially on conformance to this schedule, which means, in school, you are graded by midterm exam score or homework score and other things, right? In this big organization, such as in manufacturing company, you are evaluated with respect to some other things. And this MRP-based planning system, the key importance is, did you keep the schedule? Okay? You're the engineer, and you have the high chance of working in engineering department. So, for example, for structural analysis, they give 10 days of lead time. During 10 days, you are supposed to finish the structural analysis. If you finish that analysis in 10 days, you're good. If you finish it in 11 days or 12 days, you're bad. You finish the analysis in 8 days, doesn't matter. Okay? It's a MRP system. Okay. What's the good? It can capture the dependency of demand, of material, of information, of resources. Without it, in EOQ and other things, everything does not interact with each other. But I'd like to ask a question. Can you integrate this inventory models with MRP? But sometimes some work is done like this. You may want to apply independence demand, because this one demands something from this one demands something from this one, and there is no dependency. You can easily apply those one, mix your EOQ model and any other models in this kind of situation. Also, the answer is there are plenty of opportunity to mix and suggest or propose new things by combining all the concepts. Okay? We know how to control the similarity between products, right? Group technology, right? By controlling level of similarity, some parts are sometimes two different parts, but sometimes just similar one part. Okay? If you do that for some specific situation, and you can apply MRP and sometimes that, or at the same time you can apply both of these approaches. Okay? Look around in shipyard or offshore engineering field, and there are many things. And if you do the literature survey, there are many possible application area. Okay. MRP-based planning, shipyard guys are really familiar with this approach. They know everything about how this MRP works and when to do and what's your customer. They are just so familiar with this approach. So when you are work with MRP system and you, at the same time work with the shipyard, it's very comfortable. And COTS is a commercial off-the-shelf software. The software out there you can just purchase, like MS Microsoft Word or Excel. There are many commercial software out there, very good one, which can do this MRP, MRP2, and ERP. It's a good thing. But nothing is perfect. You know, in example, we assume that there is lead time, constant, predefined. There is no random variables there. However, there are, as I mentioned before, you can mix and match and integrate with many other inventory control model. Also with probability approach. In many inventory model, we assume that some variables are random variables, and we derive the inventory model based on this statistical distribution, such as demand follows the Poisson distribution and the like. Those approach can be applied here. But however, MRP does not like those kind of random variable things. Anyway, there is a way to apply that. And the thing is like this. As I mentioned before, your lead time, your given time is 10 days. Okay? You're just good if you finish your job in 10 days. Which means there is no incentive for you to finish this same job in 9 days. Why bother? Which is eventually bad. Okay? And also, you guys are evaluated how precisely you keep the schedule. So people, you know, honestly, this job takes about 10 days. Then the scheduling guy, planning guy will ask you, how much time do you need to finish this kind of job? Then people tend to answer, well, I need 12 days, right? If they answer 10 days, you have to work like hectic days, but so there is some kind of incentive and even increase the standard lead time because it's good for the workers. So application of this MRP has this kind of drawbacks. And more drawbacks. It does not deal with the inventory. Concept can be integrated with inventory control model, but however, this one basically does not consider any inventory. It only deals with the lead time in planning. So think about it. At some days, you have to pass your final product to the next customer, and it could happen by some fixed schedule, and you are you are supposed to keep the schedule no matter what. Then there is also people tends to make up a little bit more, and in that case, people have some kind of incentive to increase the inventory. If something happens, you can still keep the schedule if you have plenty of inventory, right? So, but increasing inventory is, in overall sense, it's not good, right? It's a money sitting there doing nothing. Okay? And this MRP cannot identify the critical path. Critical path should have the top priority in doing everything, but it's very hard to recognize critical path. However, because of this drawback, there is some way to integrate critical path method and this MRP. Okay, you can easily guess how you can do this. And also this planning requires lots of information system and computer system. Without it, you cannot do. Okay, one drawback. Okay, let's resume. Just-in-time production system, it's another name of Toyota production system. And before going into that definition, we know what the mass production is, right? If I bring you with some factory and let you have some time to observe what's going on, can you say this is mass production or not? Of course, you should, right? You have to know what is mass production system and what is not, right? There are few characteristics can define the mass production system. Large lot, push ahead, regulated by MRP and the like. Okay? The key concept of mass production system is harness as much as possible from economies of scale, sorry. If you do repetitive job, do once again and again and again, like stamping your spoon, pom, 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 like this, it's really economic. Okay? This is the reason why we do group technology, right? Okay. The other end of the concept is lean production. Do you know what lean means? Lean. If you go to a market and there are many beef there, lean meat is a meat with less fat. Okay, lean. Have you ever heard about a lean bun system? A new economic engine system? Lean bun. It's a new kind of gasoline engine that the ratio of the gasoline and air, so the gasoline part is much more reduced than conventional engines, so it's a lean bun engine. The meaning of lean is something less, something without fat, and something without non-necessity. So lean production is utilizing minimum amount of people, inventory, equipment, only absolutely necessary amount is used to meet the customer demand. It's a concept of lean. Okay? No redundancy, no safety stock, no nothing. Just what is required, only required, absolutely required. That's the concept of lean production. Okay. Well, something is broken because of, there are some characteristics which can tell is this a mass production system or not. Well, mass production system. Okay, let me. No. In mass production system, you can identify the mass production system by watching this thing. They tend to use MRP style, and they have warehouse storage, and they have push batches. Even though the next workstation is busy doing something, this workstation is finished according to the schedule. They just push those material to next station because it is defined so in the schedule. And there is a few changeover. Changeover means a tool change or setup. Okay, you know, in order if your workstation is stamping spoons, and if you like to stamping fork instead of spoon, you have to change the die. Those kind of changeover is very rare in mass production, and in mass production system, every machine is kind of specialized for maximum speed or something. Changing over of this die takes very long time. Okay, they do not do very frequently. Also, because of repetitive job, automation is everywhere. So for sometimes you cannot find any human workers in big, huge company. And machine is leading the production. You know, schedule is based on this machine's capacity and lead time and the like. Human operators are just helping machines. And efficiency is the key focus. And but there are many hidden waste. And US manufacturing system doing this one very frequently. Okay? It's a mass production characteristics. How about the lean production? You know, originally I made this slide. This one is mass production and this one is lean. But for some file corruption, you cannot see. But anyway, they do not use MRP. In lean production, they use just-in-time production. And they don't use much of the storage and warehouse. They do not push batches, they pull the batches. So, the next workstation actually pull the order. And without the pull, if my next workstation is not asking anything from me, I'm supposed to do nothing. It's just in time. And they ask me something, then I do something. Okay? And there are frequent changeovers and automation, possibly, but not so much as in mass production and the like. If you think of the kind of opposite way, then it's a characteristic of lean production system. Okay. Just-in-time production system, in order to understand it, first let's think about the logic behind of it, and let's observe these categories: Japanese approach to productivity and the like. Okay, this is the logic behind the just-in-time production system. Process A, B, C. If you move with batches, battery is a big bin of identical part. Once process A produces this much about circles, and once job is done, it pushes to next process B. And at process B, they work on the same part, and again and again and again. So lead time to make the final product is about, let's say, every process, it takes about 10 minutes to process everything. Then the lead time to get the first produced product out of this 3 sequential process is 30 minutes or so. But in this case, once you process one circle in process A and just give it to the next, and then process it and just give it to the next, then lead time will be much shorter. Okay? From here and to here is your lead time. And from here to here is your lead time, right? If you move one by one. That's the concept of just-in-time. Elimination of the batches. Continuous flow. That's the logic. Okay. Bottom line is like this. You only do something when it is absolutely required. Okay? But it needs to orchestrate operation to get over the obstacles which prohibits this kind of approach. Ideally, it makes sense, but in reality, there are very good reasons that people use batches, right? Okay. Question about this just-in-time approach? Okay? Right.
Both of them at the same time.
Yeah. Continuous flow, that's the characteristic of a just-in-time. One by one.
Batch and queue. The batch and queue, that one.
Batch what?
In this slide, batch and queue.
In this slide?
On the first batch and queue.
Lead time, 30 minutes.
That one is...
For total order. Right?
That one is also just-in-time.
What?
The first one is also just-in-time.
Is this for just-in-time? No. Mass production. Yes. Okay. Do you understand the lead time for the batch and queue is 30 minutes for all the 10 black circle? You have to wait 30 minutes to actually get the first black circle in first system. But in here, let's say, 10 minutes, so it requires 1 minute of processing time, right, per thing. In here, you only have to wait 3 minutes to get the first black circle, right? Okay? It's a lead time. Okay. Takt time, T-A-K-T, is originally German word because it's not English. English, if it's English, it's a T-A-C-T. Takt time is time of metronome. Following this metronome, you make things hard. It's the which synchronize the pace of production to match the pace of demand. Okay, so in previous example, because it's an illustration, we assume that every part requires 1 minute to do the manufacturing for the simplicity. So 1 minute, 1 minute, 1 minute, there is a 10 units. So in order to produce it, this batch requires 10 minutes at A, and this batch requires another 10 minutes at B, and another 10 minutes at C. So total 30 minutes is required. But anyway, for one circle, every machine work on one machine each. Okay? In just-in-time, they do not use batches. So once one circle is processed in A for about 1 minute, it just passed to the B for another 1 minute and passed to the C for another 1 minute, 3 minutes. Okay, so first black circle come out of the system in this mass production in 30 minutes, in the just-in-time 3 minutes. Reduce of the lead time greatly. Anyway, we said 1 minute. Everything is required, or the manufacturing process requires 1 minute. Those 1 minute is kind of takt time on that previous example. So in every 1 minute, 1 unit coming out of the system, right? For example, in automobile manufacturer, let's say 1 automobile are coming out of the system in every 3 minutes, then all the factories this 3 minutes should be kept in every possible processes is there. After 3 minutes, a car is coming out, customer demand coming out, right? Then the previous workstation, just before that, it have to do something in 3 minutes, right? In order to feed it, okay? 3 minutes, 3 minutes, 3 minutes. So ideally, if all the factories workstation work in accordance with this 3 minute pace, then it's a takt time. Okay. It's just brief calculation formula. Takt time is defined by the final demand. So operating time per shift divided by customer requirement per shift. So this much of a time is there, and this much of unit are required, then end up 59 seconds, which means in order to satisfy the customer demand during that shift time, you have to make product in every 59 seconds. If that's so, your factory system's takt time should be 59 seconds. Okay? Question about it?
If the process B is broken by some accident, the charity is affected by the another process A, B, A and C. really wonder in this situation.
Very good observation. If something unexpected happens, just in time, cannot handle it. You know, in Japan, Fukushima area, tsunami hit the area, and there are 4 plus automotive part and automotive company there. If you have plenty of inventory, which in sense it's a bad money sitting there doing nothing, then even though the factory is shutting down, you can still satisfy the customer demand because you have an inventory. And during that time, you can do some work to reopen the factory, right? That's possible because you have a large inventory. But in just in time, you don't have such inventory. So if the factory is down, you cannot satisfy customer demand because there is no system to produce it. But in normal time, this been a very successful. Toyota production system is originally developed by Toyota, straightforward. Toyota is founded by Mr. Toyota, simple. And they haven't started with the automaker. They was kind of cloth maker. You mean 방적. From the thread, they make cloth, the cloth raw material, and this the machine. This Toyota's invention is at the clothing making machine. It is really pain in the pants when there are numerous hundreds of the vertical thread, and some shuttle is going back and forth very frequently to make the cloth, right? Basically, this approach. If one thread is cut, then everything is ruined, right? So, if a thread is cut, the machine should be shut down instantly. In order to do that, even though everything is automated, workers are just observing the machine. That's the standard at the time. Mr. Toyota's invention is he make a automatic shutdown system. If something is broken, the machine is automatically shut down. So it eliminated the required intervention of the human operator. Okay? Based on this this invention, this guy was very successful, and then he moved to the agriculture machine company, and then this becomes an automobile company. Okay? And his idea is basically eliminate waste of everything. Like this. Machine is automated, but human worker has to be there watching if it's working or thread is cutting or not. When thread is cutting, operator is to shut down operation. It's the only value-added process. Observation does not add any value. Do you know what I mean? If you make something, it actually adds up to the final product's value. But in order to make it efficiently, you do scheduling and provide some stationery and payroll calculation. It does not actually add value to your final product. It's just supportive product, supportive work. And his idea is, if it does not add value, it is waste. So, question is, does the inventory add the value to the final product? No. it can make your life easier in planning. But if there is a Hyundai Sonata, some price tag on it, even though this car is sitting there in tens or millions in the inventory or not, does not affect the final product at all, right? Inventory does not add value. So inventory is waste. Okay? You know, material handling, does that add value? Material handling is like this. You know, there is a conveyor belt moving things, and the people, when the chassis of the car is moving, workers are supposed to put the wheels on it, and it goes to the next workstation, and workers now put some seats on it and the like. Adding wheels and seats, those are value-added operation. But moving the car from here to there, it does not move any values. The car price is exactly the same, even though one car moves 10 kilometers inside of your factory, or the other car moves 100 kilometers in your factory, but it does not make any changes in the final product's value. So what? Okay? Material handling, non-value added operation, which is waste. Okay? Tool changing, waste. Machine down, waste. His idea is, if you think in this way, if something is absolutely necessary, which means in order to make a car, you have to do something very special, very, very, very absolutely thing, like welding, assembling, or the thing. Except that everything is waste. And his idea is reduce the waste because it does not add any value. And first one is, since inventory is waste, let's remove inventory. Okay? Lead time, like this. You know, if lead time is very long, the next workstation have to wait for part to arrive. This waiting does not add any value. Waste. Eliminate those waste time. Okay? Concept is like that. Okay? And those concept has evolved in many decades, so now become just in time. Okay? Let's call it a day at this point, and let's continue on the explanation of tech and teach time and the like. Okay, thank you.